Welcome back, guys. Today we are going to solve a problem which states that we are given an array of integers, and in that every element appears twice except for the one, and we have to find which is appearing only one time. That is the problem, right? So, for example, this array 2, 2, 1, this 2 is appearing two times, but 1 is appearing just once, so 1 will be our answer. And similarly, in the next example, this 4, 1, 2, 1, 2 array we have given. Here 1 is appearing twice, 2 is also appearing twice, right? Only 4 is appearing once. So we have to return the 4 as an answer. So before we start coding, let's think how we can approach this problem and what can be the possible solutions of this problem. So for example, we are given this array 4, 1, 2, 1, 2, right? Now, what can be the most obvious solution, right? As we have to find the element which is occurring only once. So let's start with the brute force approach. That is, we can check each element if it is occurring twice or not, right? So we can start, let's say, from the 4, right? And traverse whole array and see if 4 is occurring twice or not. In this case, we know that 4 is occurring once, so we can return 4. But let's say 4 is not at the first place or is not our answer. Then what we will do is we will move to the next element and then again we'll traverse the whole array, right? And so on. That's how we will do, right? So if we find any element occurrence, basically we can maintain a counter, and if we find any element occurrence is 1, then we can simply return from our loop and return that element, right? So for each element we are iterating through the whole array, right? That means we are looping first time from 0 to n, right? And this first loop is to extract element one by one. Let's say first we start from 4, so now we have 4. Now just for 4 we have to check whole array again, right? That is 0 to n again, and assuming n is the length of the array, right? So we are having two nested loops, right, in our brute force approach. So time complexity will be O of n square, right? As we are using two nested loops, right? And n is the length of the array, right? And as we are not using any extra space, that means we can have say that our space complexity is constant, that is O of 1, right? But this is the brute force approach, and for sure there are a lot better solutions than it. But whenever we have any problem, we always start from the brute force so that we can get intuition how to make it better, right? So this is the brute force one, and now let's think how we can make it. Now let's think of a better solution, right? So one thing we are sure about in this problem that we are dealing with the occurrences of the elements, right? We know from the input that every element is occurring twice except the one, and that one element is occurring once, right? So we are dealing with the occurrences or frequency of the element, right? That means whenever we have such situations, the first thought we can always have is hashing, because hashing will maintain how many times a element is occurring, right? So we can maintain a hash table for each element and see how many times it is occurring, right? So what we can do is, let's say for hashing we can have an hash array, right? And we can store each element occurrences, right? But the first question will be what should be the length of the array, right? Because we are not sure how much the length of the array should be. So first of all, we need to find the length, and the easiest way for the length is whatever is the maximum element in the input array, we can take the length plus 1 of that element. So here this 4 is the maximum element here. So what we can do is we can create an array of length 5, right? That is, let's say we can give this array as 0 index, then first index, then second, then third, then 4, right? So this is an array of length 5, and I have wrote down the indexes from 0, 1, 2, 3, and 4. See, that's why we are taking the max value of this input array, because we know that we don't need to store after this, right? So now let's start storing, right? So below I have written the indexes. So first of all, we will traverse our input array, right? And we will see this 4. As 4 has occurred once, so we'll place this input as 1 here, right? Now we will go to 1. So for the first index, we will place 1 because first 1 has occurred only once now. Now this 2 will come, so at second index, we will place 1, right? Now 1 is occurring again, right? This one. Now what we will do is we will increase the counter what is present at index 1, so it will become 2, right? Now again 2 is coming, so at index 2 we can increase our counter by 1, so this will also become 2, right? So this is 0. Initially we assume that all this is our 0. So this is our hash array, right? That we have maintained the count of each element at the respective indexes. So index 1, that is, it indicates the element 1 has count 2. This index 2 indicates the element 2 has count 2. And this index 4 indicates that element 4 has count 1, and so on. Okay, so we have maintained this hash array now. Now what we can do is we can loop through this hash array and see if any element has 1 in it, that is 0, 2, 2, 0, 1. So we will find our 1 here, right? That is, it indicates that this index is occurring only once. So we can return simply the index after the loop, that is 4. So it indicates that 4 is a unique element, right? But this approach has some issues or problems in it, right? We will discuss it, but let's see what is the time complexity. As we are not using any nested loops and we are looping, you know, 2 times individually, first to fulfill or insert values in this hash array, and then again looping through this hash array uh, to find the unique element. So overall time complexity here will be order of n, where n we assume the length of the array, right? Now coming to the space complexity. What will be the space complexity? That is a question. I told earlier that the length of this hash array will be the max element of the input array, right? Plus 1, right? So the space complexity will be a variable, that is the max plus 1, where max is the max element in the input array plus 1. That will be our space complexity. It is a variable. We can never say precisely what is the space complexity. Okay. Now, what is the problem in this? First of all, in this hash, especially array approach, we are using indexes to store the occurrences. That is this 0, 1, 2, 3, 4. We assume these are the elements, right? Our indexes. But what if this input array has negative values in it, right? Here we assume only the positive ones. That is the one drawback of this hash array, that we can't have or may not be store negative values using this approach, right? And secondly, let's say we have this, instead of 4, let's say we have 10 to power 4 here, right? Then in declaring a hash array of 10 to power 4 plus 1 is a big memory, right? That itself is a big memory. So that is also one problem with this approach. So this array data structure for hashing is not at all a good idea. So what we can do is we can simply use JavaScript objects, right? Let's say this 4, I can make it as a key, and its occurrence I can store it as a value. Then again this 1, I can have a key and its occurrence as its value, that is 2, and this 2 again as a key and its occurrence as its value, right? In JavaScript we can store this as a hashing object, and we can loop through this hash object, right, and check the key which has a value 1. So this 4 key has a value 1, so we can simply return 4, right? So hashing is a better idea, but hashing with array is not a good idea, right? But still, we are using extra space. If hashing is a good or bad, or any data structure that we use for hashing, but in the end, we know that we are using this extra space, right? Now, let's think, is there any way that we can remove this extra space also? Because time we have optimized of n. Now let's think how we can optimize this space as well in the next. Now coming to the optimal solution, right? For the optimal solution, that is a observational based. Okay. So here we can see each element is occurring twice and one element will be occurring once. So as I have told in previous videos, one thing that is XOR operation, and what are the quality of a XOR operation. If you remember, like we did a problem in which we have to find the missing element in an array. I will also attach that link in this video information. But in that I have told you guys a XOR operation special properties. So let me tell you again. Always remember XOR operation has two things. First one is any number XOR with itself will give you 0. Okay, just remember. And any number XOR with 0 will give you that number. Okay, these two properties you should always keep in mind whenever it is XOR operations. Okay, now let's see how we can use that property. Okay, so what we can do is we can simply traverse our array and start XORing each element. Okay, now we start from the 4, so let's write 4. Then we move to the next element, that is 1, so that is 4 XOR 1, right? Now we go to the next element, that is 2, we can do XOR 2. Again, the next element is 1, so we can do XOR 1. Again, the next element is 2, we can do XOR 2, right? Now just remember these properties. Any number XOR with itself will give you 0, right? So this 2 and this 2 XOR will give you 0, right? And this one This one XOR will give you 0, correct? Right? Now let's write it down. 4 XOR 0 XOR 0, correct? Now again, these zeros or 0 will give you again back the 0. That means 4 XOR 0, right? Now from this property, that any number XOR with 0 will give you that number itself. So it will result into 4. That is our answer. Okay. So we can do XOR of all the elements as every element is occurring twice. That's why we are able to use this XOR property. That means this twice occurring will cancel out each element by themselves, and the one which remains is the answer, right? So here we have used we have just iterated this array once, so time complexity will be O of n, where n is assuming the length of the array, and we are not using any extra space, so it will be constant space. So the space complexity will be O of 1. Right? Now we have discussed all possible solutions we can think of in terms of optimization, starting from the brute force to this optimized solution. Right? Now we have understood the thought process. Now let's go back to our code editor and start. Now we are back to our code editor. Let's code this solution. So first of all, before we start, let's see what we are given and what we have to return. So here we are given this nums array and we have to return a number, and that number should be which is occurring once, right? So as we decided or discussed in this optimal approach, we can simply loop through our array, and this nums dot length we can do. And what we have to do is we have to XOR each and every element, right? So we can create a variable where we will store the result and initialize it with 0. And the reason why I'm initializing it with 0, because any number XOR with 0 will give you that number. That's why I am initializing this result with 0. So what I have to do is we have to just XOR each element. So I will write nums of I, and in the end the result will contain the element which is occurring only once. So let me return this result and try to run this. See, all the three test cases have been accepted. Now let me submit this solution. So our solution is submitted successfully, and as you know, we use JavaScript to submit our solutions. So if you guys have any doubts or any issues or anything regarding all the approaches, and if you try to code brute force or hashing approach and you find any issue in your code or anywhere, you can just write down in comment section and I will be ready to help you out. So that's it for this video now. Let's meet in the next video. Thank you.